we go. All right, everybody, welcome. Is there enough light in here? The lighting's kind of weird. I think it's a little backwards. Oh boy, a lot of options. Okay. All right, let's go with that. So like I said before, we are going to stream these. There's no video, so no one online can see us right now, but they can hear us and they can see the presentation. So welcome, everyone. Like I said before, these presentations are really designed to be a flavor, starting point for new people, but there's a lot of depth too. So, for people who've been involved before, they want to learn how to kind of take the next step, or how do you get even deeper than you've already gotten on this. We'll get into a lot of that stuff. At any point, if anyone has any questions, raise your hand, or even if you want to just interject, that's totally fine. Very informal. This is for everybody, to learn. And if there's something particularly interesting, just let me know, and we'll go deeper on it.
It works.
Cool.
Just wanted to see if it did. Now I got to figure out how to turn it off. There we go. Where did you find it? It's just on YouTube.
If you search YouTube and you search for the neutrons.
Yeah, the neutrons. I was just curious if it was actually working.
Yeah.
I'm missing other ones that I wanted to use.
Oh yeah, so they'll all be on there, and hopefully useful. All right, so here's what I'm going to try to get through in this presentation. There's a really big middle point here, which is how you break down a game, and there's a lot that goes into that, which is what your team makeup is. Maybe it's all new people, you're a rookie team. Maybe you've had a bunch of seniors graduate and you're trying to kind of focus and whatever. So there's a lot that goes into how you break down a game and make decisions. So that's why it's a separate presentation. I'm going to do that after this. So there may feel like there's like a little bit of a gap in kind of the process you would do. It's because of that. But here's what we're going to try to get through is understand goal setting and its importance, and I'll hopefully be able to explain why I believe that. And we'll just start talking about the process of setting those goals for your team, and then we're going to get right into some of the engineering aspects. So designing for simplicity. There's a lot of kind of real quick tips and tricks around that, and rules of thumb to keep in mind. We'll talk about group decision making, something that our team always struggles with. Every team does, and just having a good mentality around it is really important. We're going to talk about COTS items and their role, especially force multiplying the resources you have. So this is where even small teams or inexperienced teams can be extremely effective if you're really smart about how you pick and choose where you implement your actual resources you have. We'll talk about some game time strategies, so stuff that happens actually on the field and off the field. And then we'll talk a few case studies of some robots that are pretty interesting and had really successful years by really focusing and keeping it simple. So real quick, my background, I'm Brandon Holley. This is my 19th FRC season. I started when I was in 8th grade. This is my 14th season as a Team 125 mentor, and I've been the lead mentor for about 11 years now. So there's about 14 full iterations of trial and error behind all this stuff. It's not to say it's the only way to do it. Team 125 has a lot of really unique characteristics that other teams don't, as far as its makeup and everything, but there's a lot of really fundamental underlying stuff. So hopefully it helps you. That's the whole point. My day job, I work for Sonos Incorporated. We make wireless speakers. I work in downtown Crossing. And if you're looking, sorry, it's all right. And if you're looking around at events, I chair the Boston district event in Revere. I chair the Beantown Blitz, and then I also coordinate the local kickoff here if you guys come and pick up your kit. So if you have any questions after this related to any of that stuff, I'm happy to answer that stuff too. So this is a really important part, and it's defining and the starting point of goal setting, defining success, and it's different for every team, and that's totally okay, and that's a big part of being a team and being a healthy team that's growing and understanding what you're trying to do in the future. So today's focus here is on-field success. Like I said in the other room, that's not to diminish off-field success. There's a number of different ways, both like through awards, which is kind of the typical way people think of off-field success, but through strengthening partnerships with your schools, with your sponsors, recruiting. There's a billion ways your team can be successful off the field. This presentation is focused around how do you get better on the field, and that's why. So real quick, I know some of you have teammates with you. If you don't, that's fine. But real quick, take a minute. I want you guys to come up, especially obviously if you're the returning teams. What's the single greatest accomplishment your team has had ever? So not in the last year or whatever. What's your single greatest accomplishment? Just take a minute. I'll come back and I'm going to ask you guys to share a few of them. All right, everybody have something that they'd be willing to share? Go ahead.
See, we're a new team.
Yeah.
But I mean, at the very least, we met consecutively.
Yep.
And so we've got a perfect number of people.
Yep. Momentum.
Yeah.
Cool. That's awesome. So, and that's a great way to think about things going into a very long road, ahead of you. But that's awesome that you have that attitude. Anybody else? Yeah.
A teammate at Einstein last year.
Nice. How was that?
Good.
Yeah, good. That's it. Yeah.
So we're 13 years old now? We're 757.
Yep.
1757. And 2 years ago we switched up and changed mentors, everything.
Okay.
And, we made it. We got invited to nationals.
Nice.
Which we've never even gotten remotely close to, and we had to turn it down because we had absolutely no ability to carry it out.
Yep.
We were just like, God no.
Yep.
But then we crashed last year, so we're trying to figure out how to do it again.
So it could be good, thing in the future to try to get back to there and then actually
It
go.
was a really good feeling considering there were only 7 people on the team.
Yeah. Yeah, for sure. That's awesome. Yes.
So for this team, my best ever was 2010, and we made it to Worlds, but it's the people who are on to now. So best success was making finals governors after 9 days for line selection.
Yep. Yeah, that's awesome. Governor's Cup was pretty wild. Cool. Anybody else?
It's not for FRC, it's for FLO.
Yes.
Last year, in 2 years consecutive, this team, this was first event to take, and second year they made it national.
Awesome.
And the excitement and everything underneath that, I can see that chemistry of this working together in a unity.
Yep.
That made it.
Are they still together? Now that,
Yeah, you're in FRC also.
so now you're doing FRC together. That's awesome. Is all your first year in FRC?
Dutch and OP going through this. A couple of us is like a third or fourth year.
Yeah, but you have some new people joining. Yeah, that's cool. That's a really cool story. Anyone else? Yeah.
So our first year ever qualifying for Worlds was 2017, and we went to Einstein.
Yes, you did. Yeah, that was pretty cool. All right, cool. So, I mean, I like always hearing those stories. It's a cool part for me. And then, I like hearing them, at the end of the year, because we're all going to see each other. That's a big part of days like today. This is not the last time we're going to see each other. We're going to be seeing each other a lot over the years. So it's cool to be able to see you guys again and hear how things went and all that stuff. So I encourage you to talk to other people too, because really FIRST is a huge networking opportunity, and it's a big part of having a team that's plugged into the community and all that. So the point here is that everyone can be great in their own definition, whether it's making the jump from FLL to FRC, and maintaining a high level of success, to getting back-to-back meetings and getting a team together and having a successful season as far as getting out there and competing, to making it to Einstein or whatever you have to do. Anyone can do that. The big part is how we get there, and everyone's path is going to be very uniquely different, and that's sometimes it's hard for teams to realize, because if you try to emulate just the best teams ever, and you just try to copy what they do, and you don't have that same infrastructure behind it, you're going to really struggle. And so, that's the whole point here. And so one reason it's important, and this is obvious, I think, to a lot of people, but there's some interesting things. On-field success has some like actual tangential benefits to the team. Obviously, team pride, feels good. I bet you guys felt pretty good after your 2017 Einstein run, where, the team was feeling pretty good. Maybe you got a big boost of, new students on the team, as you got to show off, or the school got more interested in things. So you get new students, new mentors, parents maybe become more involved. Good examples, like this I've seen happen so many times. You go to, qualify for championship, and you struggle and you scramble to get there last minute. In that scramble, you'll find parents and you'll find support people that you didn't know were around the team. You kind of become this vortex that pulls people in, and that's a really cool moment. And so big part of it is like capturing that and maintaining it moving forward, and not making it a fire drill.
The side effect for us was we had a ton of people come out of the woodwork that wanted to be involved. And we really had no ability to know what to do. Yeah. So that's like, you didn't know that was there. Now it's there. Hopefully you can prepare, and, as you go forward, be ready for it. And then a cool one that I've always liked is the local media attention. And, you could always use it to attract sponsors and stuff like that. So kind of have to always be hustling. That's how I always think about these things. Like, if you have momentum, if you have something that's worth showing off, why don't you invite a few sponsors, or a few parents, or, maybe, whoever your team may be connected to. So that's a actually fundamental part of on-field success, things that you can actually get. So a big part of this is setting goals. And the reason I stress this so much, I'm not someone like when I have a performance review in my job, it's not like I'm treating that performance review and the goals with immense weight. Really, for a team though, that's because it's my individual thing. For a team, it's really important that everyone's aligned. This is why setting goals is important. It's not so much what the goal is, it's that everyone agrees that that is the goal that we're going after. And that's because you can think even the most basic examples. You're trying to break down a game, and you're trying to figure out what robot you're going to make. And someone will propose doing everything and doing, everything really well. And people who've been in it before, they may say, oh, well, we know we can't do that. People who really struggled in the past, maybe with an autonomous program, they'll go, well, I don't know how we're going to ever be able to do that. So you need to be aligned. You can't have half the team trying to go this way and the other half the team go that way. So really, really focus on the goals. And a big part of it, like I said, is building the consensus around the team. What are you guys trying to do? And then that's going to become your North Star. That's going to become the thing that the team always comes back to reference when we're making a decision about the robot, when we're making a decision about strategy, when we're deciding what competitions to go to. All that stuff will, be baked up into what are those goals. So, and then, I put this in here just kind of as a wow factor. A lot of people, first guys like, I want to win FRC. Like, very few people win FRC, and there's a lot of luck that goes into it. So if you make that your goal, and there are teams where that's their goal legitimately, and they get close to it or do it every year, it's not for everyone. And you may be very disappointed, if you make that your goal. But here's some other ones. Like, here's some other interesting goals that you can look at. And these are really like off the top of my head, and very fundamentally calculable. There's other goals, and you can see more at the bottom, that are a little harder to define, but are still measurable. So, being in an elimination alliance, or being in elimination alliance consistently. So everyone has 2 events in New England, making elims at both of those events. That would be a pretty strong goal for a lot of teams. Ranking in the top 8, that's a big one for people. How do I become an alliance captain? I want to choose my own alliance. Only the top 20% at an event, get to participate in that. Making it to the finals, that's 6 teams, will make it to the finals. So 15% winning the event. And this is with a 40-team event. The top 8% make that. So again, you're getting down to the the small numbers there. Winning a judged award, and you can pick what award that means. It could be technical, it could be non-technical, but you can really make that a team goal. Focus on it.
And then there's like season goals too that I would consider. And we have that luxury as being in a district in New England because we don't just have one event. We can actually look at multiple events and try to measure progress across them. So making district championship, that's a big deal for a lot of teams. Only the top 32% in New England make it, and that number is shrinking, as we go on because New England's getting bigger, and we're not inviting more teams to New England championship. So that number is going down, which means that it's harder and harder to get into New England championship. And it's historically been probably the most competitive district championship each year with how heavy and how strong it is. So stronger than a division at championship by far. So very competitive. Making elims at district championship, that's a big one. Only 12% of teams in New England do that and participate in the eliminations, qualifying for championship. And then the last one I threw in there is really interesting and something that like our team is locked in every year. And even if we go to multiple events, if we go to 3 events, like, district championship and then championship, our goal is to always do better event to event. And that can mean even if we won the first event or did very well, we want to be able, to do that, but, on a better, more consistent basis, or we want to do that with more features that we've added to the robot. So that's just a goal. It's a little harder to define, but you can measure it, and that's really important about goal setting. So again, real quickly, talk amongst your groups. Now everyone should be involved because even if you're new, you can still set a goal because we're looking ahead now. And really look at these 3 things. See how specific you can make it. See if you can make it measurable, and then you want it to be achievable, but you don't want it to be low hanging. Make it a bit of a reach goal. So again, we'll do quick. Just take a minute. See if you guys can come up with something that you'd be willing to share with the group as far as a goal for the year.
So for our team, we didn't qualify for district champs in 2018, so for our this year,
I don't think it's something that we should go into. Thinking in this first year,
well, not the first year of our team, my first year.
So how are we feeling about goal setting? Is it easy? Oh, it's easy. All right, you guys first. District champs. Cool. It's a good goal. It's a unique, having a district in New England is nice because it does give you more opportunities to kind of target goals, make it a little bit about less random chance. Someone else? What are you guys?
So I guess for us, it's just like doing the best we can.
Okay.
Just like making a robot that actually works.
Yep.
Well, it doesn't even have to work. It's just like we have to put like as much effort as we can.
We're going to make your robot work. So yeah, let's start with that goal. Your robot will work. That's the goal. We'll make it happen. I like it. Yeah.
For us, I think one of the things I'd like our team to do is to attend a week 0 event.
Okay.
We have to be ready early enough to do that instead of, putting 40 hours into the robot in the last day.
Yes. That's awesome. Yeah, it's a super good goal. And even if it wasn't a week 0 per se, I mean, even if you could just get to the point where you could be able to compete at a week 0, right? Like your competition ready.
Actually be able to, but actually
being there.
Planning to go,
Yep.
making a commitment.
Yep. I like it.
Apply some pressure.
Yep. Deadlines. Anyone else? What about the FLL crew? Yeah.
Well, our goal was that we want to keep our world streak. We made the world all 4 every year.
Yep.
We want to keep that.
Keep it alive.
And the important actually why this is very important to us because our top 20 people left, graduated out.
Yep.
So our challenge is to maintain that same peak.
Yep.
With newer people.
Yep. And so that's a huge thing. That's something that the neutrons deal with all the time. Is we had the same thing last year. I think we graduated something like 12 or 15 seniors who'd been there for all 4 years. So you're trying to maintain the same level of success, but you're losing a huge chunk of experience. So absolutely, totally hard to achieve goal, but good goal. Anybody else want to share? All right, cool. So a big part about goal setting is how your team reacts to it and how you actually deal with the results of the goal. That's both positive and negative. I talk about the negative quite a bit because that's the one that tends to devastate people more. People tend to be pleasantly surprised if they achieve their goals. But it's important, even on the positive side, if you do achieve your goal, to look back and go, well, maybe that was easier than we thought it was. Maybe we can achieve something higher. Maybe we can reach a little bit higher. But on the negative side, the failure side, this is really a team culture aspect. And it's something that, it starts with everyone, in this room today. You got to bring it back and you really have to own it. No one should be afraid of making something that doesn't work or, putting an idea out there that maybe isn't received extremely well. There's going to be ideas that are better than others. That's a fact of life. But the reality is good ideas come from all places. Interesting methods of how a prototype might work. They may come from a prototype you don't expect at all. One of my favorite examples of this is in 2014. There was these huge exercise balls that you had to shoot into a high goal or put down into a low goal. And our team talked about the idea of making like a shooter, a wheeled flywheel spinning shooter for the ball. We made a prototype, didn't work at all. We laughed it off, said, that wasn't, worthwhile. Then we see the Cheesy Poofs Team 254 out in California. They come out and they did this shooter thing, and it was amazing. And it was by far the best robot in FRC that year. And, we looked at that and said, well, that could be interesting, but we didn't pursue it. We looked at the prototype, said it was a dud, and moved on. They looked at it and said, hey, maybe we could make that better. Maybe they saw just a little piece of something that would work in there, and they really celebrated, probably their earlier failures and got to the point where they were able to lock that in and become a very, very devastating robot. So this is a big one. The last point there, the common trait among successful teams and organizations, all my years of seeing this, the places I've worked, a common trait is people treating failure, with respect and instantly turning it into motivation and turning that around. So that's just a big point. It's hard to just say that and do it, but if you keep that in the back of your mind, I think you'll find yourself starting to treat things in that way and help the rest of your team treat things in that way. So that's a big point of it. So real quick, I'm going to start shifting gears into how do we start making some of these decisions? How do we look at an engineering challenge and make a choice around what we're going to do? So engineering design process. This is flexible, right? This is one way to interpret it, but you start with defining problems, generating concepts, developing solutions, constructing, testing prototypes, evaluating solutions, and at any point along that gambit, you can go back to the beginning, and that's a big part of it. And that's a thing, the kind of the artful piece of engineering that the lead architects, the people that are really designing the thing, they're able to look and understand which ideas may bear fruit and which ideas may be dead ends, and cut off some of the longer loops. So anyway, that's engineering design process. And a big part of being successful in the field is going to be designing for simplicity. So I put Team 2056 up here. If you haven't seen them before, they're absolutely one of the most fascinating teams that I've seen in my many years. They had a streak, I think it was 23 or 26 consecutive regional wins that they done. They didn't lose a regional from the time they started the team for something like 8 or 9 years. They didn't lose.
And if you look at the robots, they're not. It's not like they went out and invented a new type of way of doing things or found a new element. They're just doing the thing that you're supposed to do very cleanly and simply and straightforward. And they're putting the resources that they have in the right places. So here's just a few really cool or really interesting tips. So one to keep in mind, everyone has a finite amount of resources, whether it's machining time, whether it's the number of people on your team, the amount of time you can meet, the amount of money you have. All those things are finite, and you want to put them on what's important. So that one leads into my second, which is a lot of people get caught up making custom drivetrains every year, or wanting to do something like a mechanism drive or a swerve drive. And we'll talk about those this afternoon if you don't know what those are. And the reality is those don't really win events. There's maybe a handful of times I can think of a robot that was a custom drive that did everything that really separated them and won them the event. They'll definitely lose events for you if they don't function well. And so that's where, thinking about using the KitBot, which is a very reliable, very robust system, should really think hard about whether we should put our time into making the mechanisms work in the upper part of the robot, or should we invest time in something like the KitBot? You want to keep mechanisms as simple as possible, whether that's, however you want to interpret that. The degrees of freedom that they have, you don't want to make, multi-jointed arms if you don't have to. And very, very rarely would you ever have to. You want to, think about things like, can I string two simpler mechanisms together instead of making one complicated mechanism? And that happens quite a bit. And that's where things like pneumatics get interesting because they're so straightforward as far as creating motion, where you can, with one pneumatic device, add a functionality to a very simple mechanism that gives you what would have come out of a much more complicated mechanism. Watch out for the cool factor. That's a big one because we're all, robot nerds. And so we nerd out over cool things. That's just our nature. And we get caught up in it all the time on 125, like things that look really cool. And we're like, wow, that'd be really interesting to play with or get after. Got to keep that in the back of your mind. Cool doesn't win necessarily. It can, but it's probably a longer path if you're doing something just for being cool. More times than not, and I think anyone who's played before has seen this, the best robots are the simple, effective ones. 2017, the gears and fuel year for those who are in first then, I go back to that year and I think about all the wasted time that people spent making shooters that they never used. Tons and tons of teams made shooters. And it was part of the challenge, but then you go and you look at teams like, and we'll talk about them later. The one that comes to the top of my mind all the time is the Outliers, Team 5687 in that year. They made this little robot that only ran gears and absolutely dominated every event they went to. They were, in the mix for winning the event or winning the event. And they just kept it really simple. So we'll talk about them later. And again, simple, effective robots, they tend to win. And there's a lot of reasons behind that. And then off the shelf, so COTS, you'll see that come up a few times. That's commonly available off the shelf products. They can be a big part of being successful. And it's really about applying those resources in the right places. So, this doesn't happen as much anymore, but it was a big thing a few 5+ years ago where everyone would make their own wheels. You make your own wheels. That's just what you do because you want them to be the right size. I don't know if anyone who's made a wheel before. Has anybody in the room made a wheel? Yeah. So making wheels sucks. I hate making wheels. So it's not to say that making the thing sucks. It's that you're putting a lot of time and energy into something that you could put into other parts of the robot. So design for simplicity, it's a big part of it. So the question is, when we're designing for simplicity, how do we weigh these things? How do we weigh making a fuel shooter that we want, strategically with designing for simplicity and focusing? It's pretty challenging to balance that. And there's a few tools I'll talk about. Everyone's done this before. Everyone's had a brainstorm in their life. Brainstorming can take on all sorts of
twists and turns. And a big part, these are things that I would recommend, tricks that we found, is you want to have a brainstorming, guide, someone who can keep the discussion on track, make sure that people are all focusing and engaging. You're not getting into what I like to call meme territory, which happens quite a bit. Does anyone know what I'm talking about with meme territory? So, do you know what a meme is? So, our team gets into these little fits sometimes where it's like someone will say something funny, and then 5 or 6 people after that will want to capitalize on that same joke, and all of a sudden after 3 minutes of discussion we're like way off in left field, we're way off track. So you got to keep the focus. So I like to let maybe 1 or 2 little jokes happen, and then boom, pull the discussion back on track, kind of balance the fun with everyone staying focused. Something we do early on in the season that's really helpful is we start in smaller groups, and then go to bigger groups, and then eventually go to the entire group. Our team's fairly large, that you may not need to do that with a smaller team. But what the smaller groups do is if you get down to a point where there's only 4 or 5 people in a brainstorming group, you guys can all have a voice. Everyone can be heard and discuss. Some people don't like talking in public. Some people don't like to share ideas with a room full of 50 people. But you can, in a smaller setting, share those ideas, see if there's any common themes and common threads. And then as you go to bigger and bigger and bigger groups, all the common threads will start coming out, and you'll really start seeing similarities. Those are things that you can pick out and say, all right, these are something that our team kind of fundamentally believes in or think are interesting. And then you'll find a few things that aren't commonly aligned or there's big disagreements on. Those are like the nuggets. Those are the things that you want to talk about and argue about, because you need to align the team. You got to pick a common goal, pick a common strategy. So aligning the things that are misaligned becomes the real important work there. And then obviously, this is something that I'm sure every team has said at one point during a brainstorming session, especially early on in the season. We want to design ideas. We don't want to design mechanisms. Let's worry about the what, not about the how. Again, big part of brainstorming, especially early on. Eventually you get to that point, but you want to talk about the high level stuff first. And so, like I said, group decision making, there's a lot of different ways to cut this. So, what I'm describing here is really just how the neutrons have done it. And again, it's like over those many seasons of iteration, our team is fairly large. We fluctuate somewhere between 50 to 70 students usually each year. We have about 15 to 20 mentors involved. So you can imagine, in those first few days of build season, there's 70 something people in a room, and everyone wants to have a voice. And we're trying to get to a point where everyone is aligned on one topic. One thing we don't do is vote. We never vote for, we want to do this design or that design, because I'm sure people have seen this too. The beginning of the year, at the beginning of the build season, everyone's in that room, everyone has a vote, everyone votes, and then by week 4 and week 5, maybe the room's only half full because people are busy, they've got stuff going on, it was overwhelming for them, they couldn't keep up, maybe. So what ends up happening is everyone that started that in that day 1 had the same weight as the people that are carrying it all the way through to the end. To carry it through to the end, you want the whole team aligned and you want to build consensus. And that's something that we spend a lot of time doing. And a big part of the way we do it is by that small group, big group transition. So we'll go from small groups to bigger groups to full group, back to bigger groups, down to small groups again. And we'll just keep going through that cycle, mixing people up, trying to attack the problem from different ways. All to try to get to the point where it becomes very plain to everybody what we should be doing based on our resources, based on the game, based on the strategy we've chosen or will choose. And quantitative, that's a big part of group decision making. Getting into the arguments of, I just feel this is better. This is something we just should do. This is the thing that our team does. We do these types of things. Like those arguments, they become very emotional. They become very unhelpful. So quantitative wherever you can. It's hard to stay to that sometimes. Some people get really passionate about things, but
That's a goal. You want to strive for the quantitative side. So who's used a weighted objective table before, or a decision matrix? So if if you've been an engineer before, it's probably something that's come up. If you've been in FRC before, you may have talked about it too. I'm just going to show you the tool real quick. It's an example of one, and it's something that you can look at and use. What this does, and I'll explain the numbers and everything in here, but what this does for me, it's not what these scores mean. These, from my perspective, aren't that valuable. What it is for me is these weights, because what you're doing is you're aligning a specific part of the robot or a specific part of the design, and the team is deciding what is important to us about that design. Then once you do that, it becomes easy to start weighting these things, because most of the time it's obvious about what type of score you should apply to each one. And then what you'll find, I think, is by the time you've gone through the exercise of applying the weights to what's important to your team, that these scores do become irrelevant. Everyone kind of eventually gets to the same point. It doesn't happen every single time, but most of the time it does happen that way. So the way these work, very straightforward. We choose what our criteria will be. So in this particular case, we're talking about a claw to grab. It was an inner tube in 2011, I think. So you can imagine just a tube that's sitting on the ground, inflated tube, and we're trying to figure a way to pick it up. We've gone through a couple prototypes, and we've now decided we've now realized we have to make a decision. So we go into, all right, these are things that are important to us. The cost of it, we don't want to spend the entire robot budget on it. It's important, but you can see relatively it was at the bottom of our importance, just enough to make the chart. Complexity, that was a big one for us. 10, we wanted to make sure that we weren't getting into something crazy. Weight, so the actual physical mass of the robot or of the mechanism. The tightness of the grip, so how securely we held the tube, important, not the number one factor. This one was our biggest one, required driver precision, as far as how easy was it for a driver to grab the tube on the field, and then the speed of the grab, how quickly we acquired it. So, and when we do the game breakdown, I'll show you how we get to the point where we're looking at this one as like being super important, and this one as being also very important. But you'll see, as we went through this, we got to the point where we said these two are super important. Complexity is a big one for us. We want to keep that in the back of our mind. And then we have these other things that we're concerned about. Once you have the weights, you give each mechanism a score, and these you can pick whatever values you want. If you want to do these 1 to 10, you can do that. If you want to do these 1 to 10, you can. In this case, we did them in groups of 5. It helps give you some separation between the final numbers, but you can pick whatever scale you want, 1, 2, 3, 1 through 10, 1 through 100, it doesn't matter. And you apply a score to them. So we did, like I said, a 1 to 5, 1 being the worst, 5 being the best. And we weighted each one of them. I'm not going to go through each one, but I will point out like what won out. And it became very obvious. If this was our most important attribute, we decided as a team, required driver precision, and this prototype got a 5, and this one got a 3, and this one got a 2, the weight of that weighed very heavily in its score. It got a 75 for that. So it put it ahead of the other ones. Even with some of the other ones, this one being slightly more complicated, maybe slightly more expensive. Speed of the grab, was equal with the scoop mechanism that we had. So you get the idea. Does anyone have any questions about this? Yeah.
So how do you come up with numbers? Is there like a scale to it?
So there is a scale. The scale is up to you as a team. So like I said, the weight in our case here, we did a 0 through 20 scale. We didn't assign anything at 20, and then we did it in groups of 5. The only reason we did that was so that the numbers at the end were like separated just by more than a couple points. That it doesn't matter. It could have been 1 to 10. It could have been 1 to 5. The same with this. This could have been 1 to 10, 1 to 5, 0 to 20. So what the scale is up to you. how you assign the numbers, like that is the group decision making. Every one of these numbers that we put in these, so not these numbers, not the calculated ones, but these numbers that we go in there, we're sitting in a group and we're all talking about it. We're saying, how important is this? This one, we all feel this is really important, and people will state their cases why they feel it's important. You'll see when we do the game breakdown, how we get to a point where we say that we need to do this in a certain amount of time. And it's because we based our strategy around scoring X amount of points in Y amount of time. And so for our strategy to be fulfilled, we have to do these things in those time constraints. Yeah.
Question for you. Where you have complexity listed, you actually mean low complexity? High score means low complexity in the way that you do your scoring?
Correct. Yes.
Just checking.
Yep. So maybe you should say simplicity, maybe be more intuitive.
Well, as you said, 5 is best, whatever best means.
5 is best.
Yeah.
Yep.
Oh.
Yeah. So complexity. This should say simplicity. I think it would be easier to understand by how simple the thing is. Yep.
At this point in your development process, how much are you invested in doing things like detailed designs or functional prototyping?
At this point in time, we've pretty much only done any functional prototyping. Detailed design work, like so anything that would be in CAD, would be in there only for the sake of like getting the right geometry for the prototype. Doing a sketch to understand the magic numbers that we need to get into the actual prototype. But at this point in the game, we basically made some wooden prototypes or PVC prototypes, powered them with like cordless drills, pretty standard prototyping process, nothing too complicated. And then some of the mechanisms were really this scoop mechanism. It was literally like a scoop. It was a shovel that dragged around the ground and we would lift it up. So that prototype took all of 3 seconds, to figure out. These other ones, the pinchy claw and the roller claw in particular, they took a little bit more. But you start really, coarse, and you put the effort into the ones that are, showing some fruit as you go ahead. Yep. All right. So that's it for weighted objective tables. The point of showing that was really just in that group decision making and how difficult that can be. You need as many tools as you can have at your disposal. I'd say we probably break one of these out, maybe once a year. Sometimes we don't need it at all in the year because everyone gets pretty pumped up about a certain design or whatever. But if you do get to a sticking point, it is important. And again, it's not about these final numbers. It's about these numbers you populate in the table, because these are what are aligning the team. Once everyone agrees on these weight, then we know that this is what is important to us as a team. You can't argue about that anymore. Maybe you can if something changes, your strategy changes or whatever, but you can't argue about it in context of the prototypes. We know that this thing is the most important thing to us, and that's why this prototype is better. So I talked a lot about common off-the-shelf parts, COTS items. I'm going to talk through them again. I think a lot of people may be aware of these, especially if you've been in first, or if your team's been around for a while. You may have a stockpile of some stuff laying around. But for new people, I think this is stuff that sometimes is hard to realize is out there. And so I'll go through stuff. If you have any questions about anything you see, just stop me. This is a very kind of informal fly through of some of the common off-the-shelf items. Like I was saying earlier, it really helps you focus your team on the critical stuff. That tends to be the mechanisms. That tends to be what your robot's doing on the field. The drivetrain obviously is part of it. 2016 is a good example. We had some defenses that the robots had to cross. That drivetrain needed a bit of consideration. You had to really think through a few things. Maybe you wanted to change the tires and stuff like that. So it's not to say that you should ignore the drivetrain, but you want to focus on the things that are going to actually score points and be advantageous in the game. So we want to spend less time constructing those little systems like gearboxes and wheels or rollers, things that can break, things that are really intensive to make. Has anyone made a gearbox here before, custom gearbox?
on a team? How'd it work out?
Really, really well, but it was a long time ago, and we had professional machinists.
Okay, so not in recent history.
No.
Yeah.
And it's definitely, given what's available today, we would never have done.
Yeah. Yep. A lot of effort, even you know, with the professional machinist, you're taking their time and you're putting them on a gearbox, which you could potentially buy or use out of the kit.
It's an edge case.
Yep.
I would never recommend it.
Yep. What about you guys? How'd it work out?
Pretty messy and time consuming.
Yeah. It's pretty common, and people do get better at it. And there are definitely things you should make custom gearboxes for. It's not to say you should never do it, but the reality is, if it's basically to spin a roller or to spin some, a shooter flywheel, some straightforward mechanism, probably could do that with something off the shelf. So, KitBot, I've talked about it a bunch already. Most teams should use the KitBot, and that's not a negative thing at all. Like, the KitBot is an awesome piece of hardware. It goes together very quickly. Who's built a KitBot before? So we help other teams build KitBots every year. So like teams like yourself that are new to the game, will help you guys put it together. It takes us about a day to put the KitBot together, get it wired and programmed. Every team out of the box could be running a drivetrain in a single day. And yet you go to a competition and you see teams that can't move, or they have issues with wiring, or maybe they'll like slip a chain and they lose a drive site, something like that. Like, all of that can be avoided if you use the KitBot, get started early. And it, again, the design for simplicity concept, you keep your resources focused on the things that matter. How we're going to pick up a gear, how we're going to pick up a cube, how are we going to shoot a boulder, whatever it is. You focus on the stuff that's going to score you points. Again, just saying the KitBot is very robust and simple.
I'm curious, we actually decided not to use KitBots anymore, and we just use VersaFrame.
Yeah, so that's another great point I'll get to, where you don't necessarily need to use the KitBot, but there are other options.
We just like that because it seems more flexible for like the
it
thing
is.
that goes on top of it.
Yep.
Basically. Yeah,
the VersaFrame is awesome stuff. It is way more flexible, customizable. You could do 6-wheel drive, 8-wheel drive, 4-wheel drive.
And you can take apart, giant stock of old VersaFrame pieces
to use again.
Yeah.
Yep. You guys have something in the back? Okay. So we'll talk about some VersaFrame stuff. Andy Mark. Everybody probably has heard of Andy Mark if you've gotten a kit before, because they provide a bunch of stuff for the kit. They're awesome. I'm going to pull them up. They have a huge amount of stuff. I don't know if you've combed through the Andy Mark website before, but there's just a huge amount of stuff inside of here. Things from gearboxes, which I'm going to click into first, to wheels, motors. If you're looking at like electrical hardware, so the radio for your robot or the Robo Rio for your robot, you can get any of those from Andy Mark. So they have all sorts of gearboxes. There's some newer stuff in here. These 57 Sport gearboxes. They're planetary gearboxes. They're pretty customizable as far as what ratio you want to plug into it. They interface with several different kit motors. They have a hex shaft output that interfaces with a lot of standard off-the-shelf parts like wheels and other gears or pulleys, rollers, stuff like that. There's some other gearboxes down here which are worth highlighting, which are for drivetrains. And you see them pretty frequently. The Super Shifter, the Evo Shifter. These gearboxes are designed to go mostly into drivetrains. They can be used for other things. I saw quite a few teams this past season use shifting gearbox on their elevator mechanism. So, a lot of people built elevators this past year. They would use the high speed on the gearbox so that they can run the elevator fast up and down and score. And then they would shift to low and they would use it to climb their robot or pull their robot up at the end of the match. So that's, one advantage there. Again, I don't know if you guys are looking at the price tags or if you can see them here. It's not cheap, so you want to make sure, again, resources applied to dollars too. You want to make sure that it's, it's not going to break the bank to buy a shifting gearbox just for the sake of having a drivetrain that shifts, has 2 speeds or whatever.
So anyway, that's Andy Mark. I highly recommend spending a lot of time looking at the gearboxes and stuff. There are wheels. The wheels are another big part that I'll mention, especially these in the upper corner here, intake wheels and elements. So it's pretty much a given that every year you're going to have to like pick something up. And most of the time, the best way to do that is with a roller intake, something that spins and sucks a game piece in. Over the years, I remember back when I was in high school, we would have to do that with, the liners that you put in like toolboxes and drawers, and it's like a foamy, tiley type liner. We would take those and like wrap them around PVC pipes and like zip tie or tape them on, and they would fall off all the time. Those are the intake rollers that we had to make. But over the years, now that we have companies like AndyMark and Vex and West Coast Products, there's these wheels that are specifically made for intakes. They're really squishy. You get some of them in the kit, so you may have a few. If you didn't use them last year, you may still have a few laying around. I highly recommend looking at them. They have a bunch of different sizes. They come in different durometers, so the different softnesses. But they're a really effective way to make an intake. I would definitely start with these if I was making an intake before I looked at other stuff, mostly because they just work and they're very simple, and you don't need to deal with making a custom roller or something along those lines. So let me get back to our presentation. That's why I picked Buster Place. So that was Andy Mark. I mentioned the gearboxes and some of the electronics, but other items that are worth noting there are the gears and sprockets. So those are just kind of the generic hardware. There's almost any type of gear ratio you can imagine. You can get there now, both in 20 pitch gears or 32 pitch gears. There's sprockets for 25 chain, 35 chain. All sorts of hubs and adapters. So there's a lot of hubs that you can attach to different wheels that'll give you a hex input or a different other input. So a lot of stuff there. Vex Pro is where the Versa chassis comes from, and they've done a pretty amazing job of putting together a kit that is really versatile, and that's I'm assuming where the name comes from. And it is all based around this VersaFrame system. So if you haven't seen it before, essentially uses 2x1 aluminum tubing or 1x1 aluminum tubing, and it has a plethora of gussets and mounts that attach to those. They have standard hole patterns drilled in them. So you can do things like mounting I don't know if you guys can see that, mounting a gearbox directly, a planetary gearbox directly to a frame. This contraption in the upper right is pretty funny, but it goes to show how versatile this system is. You can do things like mounting this clamping gearbox where you just clamp a sim and a wheel directly to the chassis. I think you can use like a 3 1/4 or 4-inch wheel and get a pretty reasonable speed out of it. You have all these large sprockets and large reduction you can do if you were to do something like an arm mechanism or an elevator mechanism. And then it's not there. The number one item I would recommend to teams who are getting into mechanism design is the Versa Planetary gearbox. We've invested in them quite a bit. We use them all the time. But one of the best things about them is the adaptability of the ratios. So you can buy a gearbox. It has several different stages you can get for it. So you can get a 3-to-1, 4-to-1, 5, 7, 9, 10-to-1 reduction, and you can swap it in and out of the gearbox. You could also stack. So you can do a 3 and a 5 to get a 15-to-1, or you can do a 10 and a 10 to get a 100-to-1. There are some things that you should be aware of if you do decide to use a Versa Planetary. One of those things is just the ultimate load you put on it. You don't want to use it in a crazy high load situation. They do have a known failure point under high load where some of the pins inside can bend and stuff like that. But in general, they're going to be extremely helpful for you if you're making an intake mechanism, which tends to be something that you're tuning and working on quite a bit, getting the speed just right. You can build the versaplanetary mount into your system, and then you can actually physically test in the final robot, in the final configuration, the different speeds. And it only takes, a $14 or $10 stage to swap in and out. And if you have a few of them laying around, you can try, a 4-to-1, 5-to-1, or 10-to-1, 15-to-1, 12-to-1, whatever you end up deciding. So versaplanetary is pretty awesome. And I'll also go to the where are the wheels and hubs? The Coulson wheels. These are a staple that teams used for years and years in FIRST. And every team that used them would have to make a hub. So you had to machine these hubs that you would press fit into the old Coulson wheel. Vex went out and they built custom Coulson wheels that have hex shaft input right into the center of them. They're great wheels. We use them almost exclusively in our drivetrains, mostly because we never have to replace them. They wear extremely well. If you've used other wheels in the past, the tread can wear out, and we'll compete for hundreds of matches and not have to replace the wheels. So I highly recommend the Coulson wheels. They also have these flex wheels, similar to AndyMark. They're a new product for them, but they seem to be very promising. I haven't used them myself yet because they are brand new. Then there's these other wheels that people like, the Versa wheels. We've used them in the past. We tend to stick to the Coulson wheels, but Versa wheels are definitely an attractive option. There are the Coulson hubs if you wanted to go with an old school Coulson. And then there's the Omni wheels and the Mechanim wheels. I really wouldn't use Mechanim wheels unless you're using them for an intake. And we'll talk about that in the drivetrain situation, especially if you're a team that's trying to just go out and be very focused and successful in the field. Mechanim wheels require a lot of programming overhead. They aren't cheap. It's money that you're spending on a Mechanim wheel and having replacements for over the year. And so for that reason, I would not recommend them for a drivetrain. However, we've used them in intakes quite a bit. Anytime that you're trying to center a game piece, if you're trying to, you have a wide intake and you want to get that ball or that object to the center of your robot so it can go inside your robot, Mechanim wheels work great for that because they have slanted rollers, and the slanted rollers both pull it in and push it, to a side. So something to consider. So jumping back over to our presentation.
I mentioned for a second.
Yeah.
VersaPlane.
Yep.
The reason we actually did that is I happen to be the only person on the team that can make dimensionally accurate parts. So with them all being pre-drilled, we actually have some chance of actually getting things somewhat close.
Yep. That it absolutely makes sense. We've done stuff in the past where we've made a jig to drill the holes for people. And
I've started doing that.
Yep.
Exactly that.
The aluminum from there is
It's a little heavy, actually.
it can add up. It's also pricey. Especially if you have to scrap a few pieces.
Yeah.
So West Coast Products, this may be a place you haven't seen before because they don't put anything in the kit. So you don't get some of their standard stuff just in the kit with you. So you may not have seen it before. But they work with Vex Pro, so they sell all the Vex Pro stuff. But they also have a few of their own products. They do their own timing belts and pulleys, which are very helpful, useful for any application that you're going to use belts on. This product is awesome, the Versa roller. So like I was describing before, the idea of making a roller intake, it comes up all the time. It's something that I'd say almost every other year you need to make some sort of mechanism that requires that. So they have a system that uses tubes and end caps and can be easily interfaced to with hex shafts and pulleys if you decide to go that route, and it can create a full conveyor system if you wanted to. So It's a good example of that. It's a really effective way to build a roller system, and it's a very unique product. There's no one else that's offering something like that. So if you find yourself getting to the point where you want to make a specific mechanism like that, you absolutely can do that. There's some interesting sensors and stuff they have here. So they sell this is a Spartan board. Basically, it's a gyro add-on board that does a bunch of other little functionality to it. It's fairly pricey, but it is a good gyro. If you are looking to add one of those, plugs right into your RoboRio. The Hall Effect board, we've used those quite a bit. That's this thing. So Hall Effect is basically a magnetic sensor, so you can use it as a limit switch. You put a magnet on one part of your robot, usually the part that moves. Put the sensor on the stationary part of your robot, and when the magnet gets close to the sensor, it'll trick or trip like a limit switch. For me, they're far superior than the physical mechanical limit switch, which relies on it clicking, mostly because that if it moves, then it means it can break, and if it breaks and it's a limit switch, that usually ends in bad things. So that's a good one to keep in mind. There's some encoders in here. I saw it. That's the magnet for the sensor. There's no picture of the encoder, but there are encoders if you need that, so you're trying to track input. The X-Pro also sells an awesome encoder, mag encoder. It plugs directly into Talons. So the different motor controllers you can use, one of them is called Talon SRX. It can plug, the mag encoder can plug directly into the Talon SRX, and it has its own firmware inside the Talon that can use the input from the mag encoder to do automatic things like motion profiling, limit switching, and all that stuff. So if you haven't looked into the Talon system before, we can help you, get started on it. But I would highly recommend it, especially for people who maybe don't have a great grasp of motion control and all that stuff yet, and you want to start getting into that and figuring out how to do it. Talons are a great place to do that. So that's West Coast products. There's a bunch of other little off-the-shelf places popping up that are specific for FRC. There's also the stalwarts of the industry. So McMaster-Carr, and anyone who's worked in engineering before, McMaster-Carr, we order something from McMaster almost every day, whether it be screws or even pneumatic cylinders, grip materials, or stock of rubber, zip ties, gloves, you name it. McMaster's great because the catalog is so easy to flip through. Their website is amazing, and their shipping is super fast. So we usually can get stuff in the next day without having to pay overnight shipping. And the ground shipping is that quick that we'll get it. So yeah, McMaster's a big one. And then even Home Depot. I don't know who's used the Home Depot website in the past year. So the Home Depot website is awesome now. It used to be terrible, absolutely terrible. But the Home Depot website is actually very good now, and they'll tell you specifically in the store down to the shelf, the exact shelf, where the thing that you're looking for is in the store. So that's a great way if you're looking for a piece that you need that afternoon or something like that. You can get to Home Depot. You don't need to spend the entire day walking through Home Depot to find your piece. So I would definitely recommend that. And I haven't tried Lowe's, mostly because there's not a Lowe's in my commute to and from work. So, but I'm guessing they have a similar thing on their website. And this is a big one. So for the head coaches out here, you get a ton of kit apart vouchers with your kit. And FRC doesn't do a great job of letting coaches know that. But you get all sorts of free stuff, and some of it's like $100 here and there, or $40 here and there. Bimba gives you free pneumatic cylinders. Go through and use your kit apart vouchers, even if you're not necessarily going to use it for that robot that year. But cash them in, build a stockpile of stuff. Usually, when I order the pneumatic cylinders, they take a while to get there. So last year, I think I ordered them on the day of kickoff or the day after kickoff. And we didn't get them until the robot was bagged. For whatever reason, I think I ordered a a type that was not in stock or something. But anyway, now we have those cylinders. We didn't use them on the robot, but we have them. We add them to our stockpile. That's all free stuff that's given to you. It's not taken advantage of nearly as much as it should be. So keep that in mind. First choice is another huge part. To me, it's the most critical part of the kit of parts. Even if you're getting a KitBot, maybe you can argue that. But first choice and filling out the credits and what your wish list is super critical to every team. Especially for the electronics. There's limited numbers of stuff. So for people who don't know, first choice basically is a lottery system for all teams. So the head coaches have the ability to go in and you're given, I think, like 400 credits or something like that. And every item in the first choice store has a certain amount of credits attached to it. And you basically put a wish list together of everything that you would want. A lot of things are limited to only allow one per or whatever. But the reality is there's a limited stock of all these things. So not every team can get one of the, PDP is a good example, the power distribution panel. There's not enough of those for every team to get one. There are about 200 first credits, I think, on first choice. But that PDP costs like $220, like real cash. So if you don't get it through first choice, which you got those credits for free, you have to now go pay $200 just to put a power distribution panel on your robot. So something that we're working on for this year is just a recommendation of first choice items for teams, things that we would get or would be helpful. Yeah.
Tell me it's 10:50.
Oh, 10 minutes. Yeah. We'll be all right. And again, buying anything expensive with that you have to spend real dollars on that you could have bought with first choice credits. It's not something you want to have to do. So first choice, be aware of it. So real quickly, jumping into the on-field strategy side of things, I think people understand why strategy is important. Having a half-baked strategy going into a match generally causes chaos, people go in the wrong direction. You want it to really boil down to the most simple, fundamental parts of the match. You want every piece of it to be outlined and understood. You want to know where your partners are going to be, try to anticipate where your opponents are going to be. And in general, a good strategy with a mediocre robot will be a great robot with a mediocre strategy. Very high level. Obviously, the exact configuration of those things will play into it. But the reality is great strategy tends to win out. So where do you start, as far as getting yourself ready for a match? And so all this stuff is focused around how do you actually get through a match and get through a competition. So you want to know yourself as far as what your team is. You want to know what your team is capable of. You want to come ready to go. You want to be well practiced. You want to have watched other events, especially early in the season. You want to see how things are playing out, learn the strategies, learn the pitfalls. You want to talk about a playbook with your team, things that you can do in a pinch if you need to. And then you want the dedicated team, the scouting team that works with a strategy team, who works with the coach, who works with the drive team. It's one machine that goes through. And when you capture this whole crew of people on our team, it would be something like 25 or 30 people involved in the scouting, to the strategy, to the coach, to the drive team. So it's a huge chunk of the team that's getting down to maybe there's only 2 drivers, 1 coach, and a human player, but you've got 30 something people behind it offering data about the upcoming matches and all that stuff. So pre-match, you want to have the discussion with you and the rest of your team, what you're going to do. You want to talk to your entire alliance at the same time so that everyone's coming up to speed about the same things at the same time. And you want to be open to change, but you don't want to just give in, because you should have a solid strategy you have. And that's always the most difficult point, is that 2 strong-minded teams or 3 strong-minded teams coming together, you got to compromise on a strategy eventually. But the whole point is that you're talking about it. You're having the discussion. You're not doing this as you're getting onto the field or the robots are already set up. You're doing this well ahead of time, and it gives you time to anticipate different things that can come up. During the match, you want your drivers to stay calm. That's the biggest job for the drivers. Just do your job, stay calm. The coach has a lot of special roles to play, the eyes and ears. They're the ones that would make any game time, decisions or, in-match strategy changes. And you want to be ready to change that stuff and be a really good communicator. After a match, you want to debrief. We implemented a system now where we use a iPad and someone stands next to the field and they record our robot for the whole match. As soon as the match is done, the person who recorded the video hands the iPad to the drive team right away. As the drive team walks back to the pit, as soon as they get to the pit, they can watch. It's only 2 minutes long, 2.5 minutes long, a match. You can rewatch your match. You can see what mistakes were made. Just like anybody else, Tom Brady, whoever, you watch the videotape, and that's how you get better. So you want to be able to do that if you can. And now that everyone, there's iPads and phones and stuff all over the place, it's pretty straightforward to be able to do that now.
Do you have sufficient access to the field? Do they get mad at you about being close?
So you can't be next to the field without a media pass.
Yeah.
We don't use our
stands then?
So we don't use our media pass for that because we want like good pictures and documentation, and this tends to be a not great video as you're swirling around the field. So what we'll do is we'll usually have someone get up next to the border of the field or maybe down in the first row or something like that. And so like I said, it tends to not be the best video. It's not something that usually makes the highlight reel, but it is enough to see what's going on with the robot. So we are getting a bit short on time. I'm going to just talk about the one specific case that I think is worth talking about out of these four. And I mentioned it before. It's Team 5687. So we're looking at all these strategies. So the combination of picking the right robot, picking the right mechanisms, getting our strategy ready for a match. Like who did this well? Who executed this to a point where you can say, wow, this is really a model to follow. These guys are what come to mind for me. So in 2017, for those who remember, the game had two real distinct elements. There was a gear element where you would run these yellow gears back and forth around the field. And then it had a fuel shooting element where you would shoot these yellow game pieces into a horizontal goal. The outliers from day one, minute one, said, we don't want to focus on the fuel. That's not something we're going to be good at. We're going to just work on gears, and we're going to design our robot around that. So they finished the robot very early. And I remember they went to a week 0, and they came out in week 0 and were scoring more gears than the rest of the teams on the field combined every match. They were just absolutely flat out flying. And it was clear that these people have been playing with this robot for quite a long time and had already figured out a lot of the nuances of it. So while other teams spent, a lot of their build working on shooting mechanisms that they didn't end up using or were ineffective, they were just running gears the whole time. They were very quick, obviously very agile, and the focused approach and well-driven with a lot of driver practice did very well for them. So they seeded first at the Granite State District. That was a week 1 event. They won the event, and they won the Engineering Excellence Award. If you remember in that game, you had to score 12 gears to get the 4th rotor turned on. And it was a big step. You only needed 6 gears to get the 3rd rotor turned on, but you needed another 6 to get the 12th rotor turned on. And no one knew, for sure how the game would play out. People thought eventually we would get to that point, but no one actually thought that at the early events, week 1, that a 4-rotor match would happen. And I think these guys did it in like every one of their limbs except one of them. They came out and scored that many gears, and it really kind of set the first world ablaze because it was like, wow, this is possible, and these guys really know what they're doing. They seeded first at Greater Boston District. They were event finalists. They won the Innovation and Control Award there. They seeded 6th in the Carson Division. We played with them. We actually chose them as the number 3 seed, and together we won the Carson Division. And a big part of that was because 5687 could score so many gears. They were about a 2-gear average, better than the next best gear team in our division. And for some reason, we were able to choose them. So real common themes, simple, reliable. They understood the game to a real exceptional level. They knew what place they were going to be on a winning alliance, and they built a robot around that. They focus on using off-the-shelf items where possible, shifting gearboxes, basic versaplanetaries if they needed any of that stuff. And they were extremely well-driven. All the robots in the case studies, and you guys can read through them in the PowerPoint after, they're all extremely well-driven. There's YouTube links in here too. You can go in and watch their matches. It's just very obvious. They know at every point in time where they're going on the field. There's never a moment where it looks like they're confused or they don't know what's going on. They have a deliberate plan at all times. That only comes from practice. So here's the big takeaways overall for this this session that we had. Set clear and defined goals because they're extremely critical to being successful. And the big part of that, again, it's not the specific goal that matters as much as the team being aligned around what that goal is. That is the big part about it, because once everyone's aligned, you can put all of your energy into it. You want to design for simplicity wherever you can. You want to take group decision-making seriously. Again, work on that building consensus item. I would highly recommend not using a voting system, mostly to try to get around that and just focus on getting the group to align on one direction. You want to use COTS items to augment those capabilities. So you want to plug in COTS wherever you can. If you feel a shifting gearbox can take you to the next level or whatever, go for that. You want to strategize effectively. This was a big one I didn't mention specifically, but I think it's a big part, and hopefully you got some of this. Become a historian. Understand FRC. Go back and look at the past. By becoming a historian, you really know what happened in the past, and you can learn from it. And then focus and simplicity, they're going to lead you to success. There's some other resources you guys can look in here. You can Google any of these. They're all awesome. Some of them are video presentations. Some of them are PowerPoint presentations. A lot of these themes come from these other presentations. They go into different aspects of the same thing. And then here's my contact info. Again, I said the presentations are going to be on neutrons.com. They'll also be on the Compass Alliance. You'll be able to find it then. And that's it. We're pretty much right at time. So real quick, if anybody has any questions, we can take that. Yep.
So when you said scoring gears,
so the actual gameplay involved a big plastic gear. So you would pick up this big plastic gear and you'd have to bring it to a place on the field and leave it on a post. You'd have to deposit it onto a post, and then that would be scored. And so the game basically involved doing that back and forth. You had to go almost the full length of the field to get another gear and go back and forth. So, yeah.
Can I ask you a question about how critical do you really think it is to have to build 2 robots so that you keep practicing on one setting?
It helps immensely. We don't build 2 robots. So I think I would say you can be successful without building 2. That's definitely possible, but building 2 certainly has a lot of advantages. The problem is if you don't have the resources to build 2, what you end up doing is burying yourself, trying to keep the second robot alive that maybe never materializes or is only half baked, and you really shoot yourself in the foot. So you got to make sure that you can handle it. Yep.
I would ask anyone who's willing to talk to me, find me at lunch. We're a first year team. And I'd love to pick your brain about some of your lessons learned. Thanks.
That's awesome. You're going to get a fire hose amount of lessons learned.
So that's a whole day right there.
Yeah, it is. Anybody else? I'm going to give us a 5-minute break. I can do the other presentation in under 50 minutes. So I'll be up here for a few.
Where are the bathrooms?
The bathrooms are right out here in the hallway. So we'll start at 11:10.
Thank you.
Yep.